All right, so continuing on with our 3.3 to 3.4 sample test, let's pick up with number 17. All right, so for 17, they want us to look at this graph and identify the intervals where the functions are increasing, decreasing, where it has maximums and minimums, both local and absolute. So to begin with, for intervals of increasing and decreasing, please remember that we look at the x values. That's what we're giving in our intervals over here. Also, we always use parentheses and not brackets. So if I'm looking at this graph, I can see it starts off at negative infinity over here because it's just going to keep going this way, right? So going and going and going and going this way. So from negative infinity to right here, it's going down, right? It's decreasing. So right here, that x value is negative 1.5. So from negative infinity to negative 1.5, it's decreasing. Then at negative 1.5, it starts going up and it increases to an x value of 2. So increasing from negative 1.5 to 2. And then at my x value of 2, it starts decreasing again. And it's going to keep doing that as it goes off to infinity. So we're not looking at the y value of negative infinity. We're looking at the x value of positive infinity. So again, we're using x values here. Additionally, the reason we're using parentheses and not brackets, even though this is a closed dot, is if I used a bracket at negative 1.5, I would use it here and here. I'd be saying that negative 1.5 was increasing and decreasing at the same time, which is not possible. So you're always going to use parentheses with increasing and decreasing. You'll also notice down here that for your maximums and minimums, those are actual ordered pairs. So you're always going to use parentheses with those as well. So it's easy to remember that for these graphs, everything's going to be parentheses. All right, so a local maximum is where your graph changes from increasing to decreasing. So that occurred right here at 2, 4.5. And a local minimum is where your graph changed from decreasing to increasing, and that occurred right here at negative 1.5, negative 3. Now, your absolute maximum is the one absolute highest point on the graph, but since this graph goes off to infinity, and you can't put your finger on infinity and say this one number right here is infinity, this one number is the highest value, it's continually changing and getting larger and larger. So when it's going to infinity or negative infinity, I don't have an absolute maximum or minimum. All right, so now let's look at this next one down here. So for this next one, we start off with over here the first value we have. It's not an arrow going to negative infinity, right? I got a closed dot right here. So I'm starting at negative 2.5 and I'm increasing until I get to an x value of negative 2. So again, remember we're using the x values, not the y values. All right, then at negative 2, I decrease until I get to 0. So decreasing from negative 2 to 0. And then at 0, I start increasing again until I get to 2. So increasing from 0 to 2, and then decreasing again from 2 to 3. So we just put this little union symbol in between when we have more than one piece to our answer. All right, then a local maximum is where your graph changes from increasing to decreasing. So that would be right here at negative 216, and increasing to decreasing right here at 216. All right, then a local minimum is where it changes from decreasing to increasing. So right here at 0, 0. So again, endpoints cannot be local maximums or minimums because we're not changing from decreasing to increasing there, right? They can be absolute maximums and minimums, but they cannot be relative or local. All right, so talking about our absolute maximums and minimums, we're looking for the one absolute highest point on the graph, and that one absolute highest point is 16. It occurs at negative 2 and at positive 2. So you can give the whole ordered pair, negative 2, 16 and positive 2, 16, or you can just give the y value of 16. You cannot just give the x value of negative 2 or positive 2. The maximum is the y value. So you're safe if you just give the whole ordered pair. All right, your absolute minimum is the one absolute lowest point on the graph, so that's going to be right here at 3, negative 10. All right, so then the next thing they asked us to do was average rate of change. Average rate of change, if you remember, was the same thing as our slope formula, y2 minus y1 over x2 minus x1. So it says find the average rate of change of each function on the interval specified Notice this is not parentheses. This is not a point. This is an interval. These are both x values. So what they've done is they've given me x of -1 and they've given me an x of +2. I got to plug those into the function to find the y value that goes with it to get my 2 points, because I need 2 ordered pairs to be able to use this formula, right? So let's take -1 and let's plug it in the place of x. So that's going to be 4 times -1 squared minus 7. And that's going to give us -3. So when we plugged in an x value of -1, we got a y value of -3. That's my first ordered pair. All right, then take the second x value they gave you and plug it into the function in the place of x. So that would be 4 times 2 squared minus 7. So that's going to give us 9. So when we plugged in 2 for x, we got 9 for y. So that's the ordered pair 2, 9. So then I'm going to call this point 1 and this point 2. So this would be x for point 1, y for point 1, x for point 2, y for point 2. So if I do y2 minus y1, that would be 9 minus -3 over x2 minus x1, that'd be 2 minus -1. So that's going to give me 12 over 3, or 4, for my average rate of change. Let's look at another one of those. So for this one, again, remember these are my two x values. So I'm going to plug -2 into my equation. So 5 minus 2 times -2 squared is going to give me -3. So when I plugged in an x of -2, I got a y of -3. So there's that first point. And then I'm going to take the second x value right here and plug it in. So putting 0 in for x, I'm going to get 5 minus 2 times 0 squared, or 5. So when I put in 0, I got 5. That's my second point. So I'm going to call this x1, y1, and this x2, y2. So y2 minus y1 would be 5 minus -3. And x2 minus x1 would be 0 minus -2. So that would give us 8 over 2, or 4. Now for 21 and 22, we're going to do the exact same thing, only I don't have to compute the point. They're going to give it to me. So you remember up here when we were plugging in like -1, we were putting -1 in for x and trying to find y. So when this says find the average rate of change from 1 to 4, they're telling you x is 1. We want to know what y is. So come over here to your graph and you can see when x is equal to 1, your y value is 5. So that's going to be my first point, 1, 5. All right, then look at x equals 4. So if I come over here to my graph, when x is equal to 4, my y value is 4. And so that would be the ordered pair 4, 4. So now I'm going to do the same thing. This is point 1, this is point 2. So I'm going to call this x1 and y1, x2 and y2. So now I can do y2 minus y1, 4 minus 5. And I can do x2 minus x1, so 4 minus 1. And that would give me -1/3 for my average rate of change. So one more of those, we've got x is equal to 2. So if we come over here and see when x is equal to 2, our y value is 3. And then when x is equal to 5, we can come over here and see that our y value is 7. So we've got the 0.23 and we've got the 0.57 that we can say this is 0.1 and this is 0.2. So this is the x for 0.1 and the y for 0.1, the x for 0.2 and the y for 0.2. So if I do y2 minus y1, that's 7 minus 3. And if I do x2 minus x1, that's 5 minus 2. So I'm going to get 4 over 3 for my average rate of change.